Hi everyone, welcome back to another lesson, and this one is a lesson on how to calculate kinetic energy using the formula Ek is equal to half mv squared. Now this is a continuation of the previous video, and it's following on from how we calculate gravitational potential energy. So this is from the same page on energy calculation. So we've done the first part in my previous video, and this one is asking you to calculate kinetic energy using this formula, which is brand new to you because this is the first day you're looking at it. Okay, so here's a question. A car of mass 950 kilograms starts from rest. So from rest, I just said V1, okay, and then it accelerates to a speed of 20 meters per second, and then it slows down to 15 meters per second. So there's three different velocities or speeds given. Okay, so use Ek equals half mv squared to calculate its kinetic energy. Before it starts, it's not moving. So because it's not moving, Ek is 0 because, why is it 0? Is Ek is half mv squared, which is half, times 950 times 0 squared, which is 0 joules. So if you multiply any number by 0, you get the answer 0. Okay, so if something's not moving, no kinetic energy. After acceleration, that means when the speed is 20 meters per second, your kinetic energy is half mv squared, or kinetic energy is half times the mass is 950, and your v squared is 20 squared. So what are you going to put into your calculator? So you're going to do half. You can put 0.5 or you can divide by 2. It's the same thing. So I'm just going to put 0.5 times 950 times 20 squared. You know, there's a square button over here. So it looks like this on your calculator, and I get 190,000. So that's the amount of kinetic energy it's got. And it's in joules because it's energy. And C is after it has slowed down. So it's a different speed when it slows down. So kinetic energy is still half mv squared, or Ek equals half times the mass. Now for V, it's 15 squared. Okay, so you just go for half. You can put 0.5 times 950 times 15 squared, and I get 106,875 joules. Okay, 106,875 joules is what I get. Okay, and then there's a part, the next part is calculate the change in kinetic energy as it slows down. So this last little bit. Okay, the change in kinetic energy is just one minus the other. So D, change in kinetic energy. So change is always represented by this triangle, which is a Greek letter, and it's called delta. Okay, so you just go 190,000 minus 106,875, and then whatever answer you get is your answer in joules. And I hope that made sense, and I hope that was useful. So it's a very short video just showing you how to calculate gravitational potential energy and kinetic energy. Once you've understood this, what we're going to do after this, and which is your homework or work for you to do, is the next page has got a few questions on energy calculations. So that's what we're going to do, and try and work your way through that, because I've talked you through both these, and this is on page 4, just the energy calculations. There are 5 questions. Okay, bye for now.